This is a level editor I've been developing using Python and ModernGL. ModernGL is a wrapper for OpenGL for Python, and I want to go through some of the features I've been developing. So so Hamster Ball Blitz, every single pixel can have one of five states, and that's either no collision, collision, grappleable, platform, or water pixel. And depending on which pixel that is, then the hamster and other objects in the world will interact with the map differently. So when I created Hamster Ball Blitz and published it 2.5 years ago, I didn't have a level editor, but I've been developing one more recently, and this is my progress so far. So I've got those five different types of pixels right here, and then I have a color palette, and I can also select my color here or change it down here. Um, and I've developed many of these tools, but I know I'm missing some. I know I've got the draw tool. I can change it to like a circle or a square, and then I can also change the size. Uh, so now, like, that's my color, and then I can draw with that. Or I could also change it to like a circle, draw with that. I've got an eraser. So Hamster Ball Blitz did like parallaxing with trees in the background for the forest area, and the anthill also had a background that was like animated. I may want to have like windows in the sequel, so if I erase some tiles, then I can actually see that background and have like an animated background rather than a static one like you're seeing here. I've got a spray tool, has a lot of different settings. Uh, and then, so that's like the size. I know I like to change it to drops per second. I'll change the color too. I can also increase the drop width. And you'll also notice, so I'm using no collision here, but I can change it to collision. And you won't see a change here immediately, but I can look at the collision map, and you'll see that it's completely blank. But now that I've changed it to collision, then these tiles, or these pixels that are changed, will actually change to collision. So when I actually load into my game, these will have collision here. This just moves the screen around. Have not developed the bucket tool yet, but I don't think that'll be too complicated. Here's the line tool. Guess I'll make it a bit bigger. And same thing with like the drawing tool. I have a square and a circle, but I'll just show one of them. There's my line. Here is a like rectangle tool. So can specify like a thickness and then draw a rectangle like that. I think this has a few different modes. So here's one with like a hollow inside. Here's an ellipse. And I know I haven't developed the hollow ellipse yet. That is actually really complicated. But I'll develop that at some point. Here's like a scatter, or like a scramble tool. So if I scramble all of these pixels, then they're all the same pixels, but they're just in a different order. Guess that kind of creates a mess because this is my collision now. And then an eyedropper just to get the color, whatever pixel I'm working with. So that's how this works. I guess I also have these to let me just scroll around my level. I guess I also have some information being displayed here. So like if I go here, you'll see the color that the eyedropper is over. And there are some other like status things that appear down there too. But for now, I'm going to load into the level. And I haven't worked on this part as much. I'm building up basically Hamster Ball Blitz from the ground up. But I want to show a compute shader that I've been working on. So these are four different quadrants. Each one of these is a 256 by 256 tile, and I've numbered the quadrants. So this has one collision pixel in it. This has two. This has three. This has four, and you'll see a number appear up here, depending on how this water jet is coming out. So there are four tiles that the water jet could potentially collide with. It'll be like this tile, this one, and this one. And this has three collision tiles in it. They're just right there in the corner. So if I face this direction, you'll see that there are three collision pixels that it's reading. But if I face up, then it'll say 5, and that's because there are 2 here and then 2 in this quadrant. Then if I face 4 quadrants, then you'll see that it reads 10. I guess I also created this animation for the water jet. But something like this, it'll read way more collision tiles. Like there are 47,307 collision tiles, or like collision pixels here that it's reading. So I use compute shaders for this because they are really fast. So this whole spot right here is 512 by 512 pixels, which is 262,144. And it's able to iterate through all of them and check if they are collision pixels in around 28 milliseconds, or sorry, 2.8 milliseconds. And that is substantially faster than something like C could read through all of these pixels to check if they're collisions. And it does that by leveraging the GPU to get just like faster checks, because each individual GPU unit can check a pixel at a time, and I can dispatch like hundreds or thousands of them, and then they can all come together to report if they've like witnessed a pixel or not. That's a collision pixel. So that's how it works, and I don't think I'm going to show the code for that right now, but yeah, that's how it works. I guess I can also show the physics a little bit. I haven't worked on this as much as like the physics for Hamster Ball Blitz, so if you want to see impressive physics, that's the better place to go. Still working the physics engine from the ground up. Oh, I guess you can also see this. This is what I drew before, and it has collision just because I scrambled everything here. Yeah, that's what I've been working on.